Here is the circuit diagram of the battery recharger unit. Now, we know that two AA batteries in series gives us about 2.3 volts. So here's my two solar cells in parallel. They're connected to the two batteries in series, but between these two sides is a diode. What is that diode there for? That diode ensures that current will always flow in this direction. So if we think about this, this is 2.3 volts here. The diode turns on at approximately a half a volt. So the voltage at this point is 2.8 volts or above when the current is flowing in this direction. So as long as the voltage here is 2.8 volts, this diode is going to turn on and those batteries are going to be in a state of being charged. Without the diode, the problem with the circuit would be that we would be discharging the batteries when the sun goes down. So if the voltage here drops, which is the case when the sun goes down, without that diode, these batteries would be discharging. Current would be flowing in the opposite direction. That's counter to our objective, which is to charge the batteries when the sun is up and to not discharge them when the sun goes down. So this ensures, the diode ensures that current always flows in this direction. The benefit of having two solar cells in parallel is I've doubled the current into the batteries. So by doubling the current, I would decrease the time it takes to charge the batteries compared. All right, so I'm now ready to construct the circuit we just looked at. Okay, so I've got my red wires twisted together. I've got my black wires twisted together. So the solar cells are already wired in parallel. I'm going to take the two red wires and I'm going to run them through this hole that I've made in the foam core. I'm going to pull those two wires through, and I'm going to do the same with the two black wires. Okay, you can see I've pushed the wires all the way through the hole, and if I turn this over, I'm going to see the red wires here and the black wires here. Okay, mounted to the back side of the foam core are two battery receptacles for AA batteries. You can see one terminal, which in this case this will be the negative terminal. The negative terminal of one battery receptacle is wired to the positive terminal of the other receptacle. And so my two batteries are going to fit in here, and they're going to be wired in series, just as you saw on the diagram. So I'm going to take this red wire and I'm going to connect it to the diode. So here I have the diode, and remember there's a little band on the diode. That is the cathode of the diode. So that banded side connects to the battery receptacle, and it's the unbanded side, or the anode, that gets connected to the red wire. And then I'm going to take the black wire and I'm going to connect it here, and that's going to be my completed circuit as shown on the diagram. Now the batteries that I put into this unit are going to be drained. I've used these two batteries in a flashlight for a while, and the flashlight doesn't come on anymore, so they're definitely in need of being recharged. But I'm going to check the voltage to just see what is the voltage of two dead batteries. So I get about 1.2 volts. So I'm going to put those batteries into the recharger unit, and then once I turn the light on, they will begin to be charged up. So now if I take my unit and I place it this side up in a window or outside, then I'm going to be able to recharge my two batteries over a certain amount of time. Let's test the current coming out of the solar cells just to verify that we are getting the current that we expect. So using the multimeter, I'm going to take the two probes and I'm going to connect them to my solar cell. So the current entering the two batteries is approximately 34 milliamps. So the next question is, how long is it going to take me to recharge these two batteries? Each battery, when charged up, operates at 1.2 volts and has a minimum capacity of 1,650 milliamp hours. That means that if you were drawing 165 milliamps, it would take 10 hours to discharge this battery. If the current flowing into the battery is 34 milliamps, then if I divide this by this, I get about 48.5 hours. So if I leave my light source on for 48.5 hours, then I will have fully recharged those two AA batteries. Now, you may say that 48.5 hours is a bit much to recharge just two AA batteries. Well, keep in mind that if I took more solar cells and I put them in parallel, I could increase the current even more. In fact, if I took two more solar cells so that I had 4 in parallel, I could take that 48.5 hours recharge time and I could cut it in half and make it 24.25 hours. So as I add more and more solar cells in parallel, I can increase the current and decrease the recharge time. Another important consideration is in a real application, I'm not going to be using an artificial light source. I'm going to be using the sun. Now, suppose that you want to power things that require more power than AA batteries have, or appliances and different things that operate off of 120 volts in AC current. So in order to do that, we need a different system. So what I'm going to show you here is a small system that one might use if they had a property off the grid and they wanted to power a laptop computer or something. So in order to store energy that I'm going to produce from solar power, I'm going to use a battery that is a 12-volt battery that has an energy capacity of 4 amp hours. Now I'm first going to check the voltage on this battery, but you can see here that I've got about 7 volts instead of the 12 volts that I would have if this battery were fully charged. So what I'm going to do is I'm going to connect my battery now to a solar cell. And the solar cell I'm using in this particular system is much bigger than the other unit that we built. This unit puts out a maximum voltage of 17.4 volts with a maximum current of about 2 amps. So you can see it's a rather large solar cell that I'm going to be using to recharge this battery.